Sure. We proceed to the next item. So we have understood what a matrix is. We have understood how to go about adding matrices. We have understood how to do the subtraction of matrices. We proceed to multiplication of matrices and the multiplication of matrices. How do we go about it? Just a minute, see. So we are on matrix addition, subtraction. So we are on multiplication. So on multiplication, there are two ways in which you're able to multiply a matrix. The first one is by use of what you call a scalar. A scalar. And the other one is multiplication by another matrix. Multiplication by another matrix. By another matrix. Now, when we have a scalar is simple. For example, if we are saying A is 4968, that is A. And then you are told to find 2A. So in this one case, 2 is the scalar here. So you are able to multiply 2 times A. So we multiply every item inside there by 2. So we call matrix multiplication by a scalar. So in that one case, if you are to get the 2A, it should simply be 4 times 2, 6 times 2, 9 times 2, 8 times 2. So you get this to be 8. This is 18. This is 12. This is 16. Multiplication by a scalar. So if you have 4, 9, 1, 10, 8, 4. Again, this is the matrix you have been used to be C. This is let's say this is B, and you have been told to find 4B. So it is simply 4 times this. So the B is represented by this matrix. So you multiply every element that is inside there by 4. Now that's that. In this case, then we shall be able to get 4B here. We simply multiply every element of that B. B is the algebra representing the matrix there. So we simply multiply every item by 4. 4. This is 9 times 4. This is 1 times 4. This is 10 times 4. This is 8 times 4. This is 4 times 4. So you're able to get it. This is 16. This is 4. This is 36. No, 18. The 18 times 4 is supposed to be 32. 32. This is 36. This is 40. This is 16. So multiplication as scalar, you simply multiply that figure by the corresponding elements of that matrix B being represented by that. So you simply multiply 4 times that. It's called multiplication by a scalar. Now, for multiplication, I had said that there are 2 approaches. One is by a scalar, and the other okay, good. So multiplication of another matrix. This is the rule. If you have to multiply a matrix by another matrix. So if the matrix we have said is denoted by R times C, row times column. So if this is the first matrix and you want to multiply the second matrix, then the second matrix row times column. So the first, the column in the first matrix must be the same as the row in the second matrix. So you to be able to multiply the matrices. So for compatibility, for purposes of multiplying one matrix with another, the column in the first row in the number of columns in the first matrix must be the same as the row in the second matrix. For example, if this is 2 times 4, for us to be able to multiply, you can multiply 4 times 3. So this matrix is compatible for multiplication, and the resulting matrix after you have multiplied will be of the order 2 times 3. So this will be the order of the resulting matrix 2 times 3. So you first ascertain that the matrices are compatible for multiplication by checking at the column for the first matrix. Is it the same as the row for the second matrix? And if that is the case, then you are able to do multiplication. So if you have 6 times 8 and we have 7 times 8, then you want to multiply them. This is a matrix. So 6 times 8 and this is 7 times 8. You can see these are not the column in the first matrix is not the same thing as the row in the second matrix, and therefore you cannot multiply those particular matrices. Now in the multiplication, we want to see what happens if we have a 2 by 2 matrix. There's no problem. We want to see 3, 2, 4, 1, 6, 8, 1. This is a row and column. By rule, this becomes 1, 2, 3. This is 3 columns, 1, 2, 2 columns. And so we have, let's say this is A, and B is 6, 9, 10. 1, 2, 4. What is this? This matrix? It is again row times column. So 1, 2. So 2 row times 3 columns. So it is a 3 by 2, and this is a 2 by 3. Are these the same? Yes, the answer is yes. The column in the first matrix is the same as the number of rows in the second matrix, and therefore such matrices are compatible for multiplication. So as I've said, the resulting matrix will be of the order 3 by 3. The resulting matrix will be of the order 3 by 3. Now let's see, how then do we proceed in doing the multiplication if that was the case? So we shall proceed in this manner. We shall be having 2 times 6, 2 times 6 plus 1 times 9 plus 1 times 9 plus 8 times 10. That is the first. So 2 times, so the row times column, this one times that. So 2 times 6, 1 times 9, 8 times 10. So we have the rows. We multiply this one with this one, multiply plus that, this times that. The second one will be 2 times. So just submit 2 times, it will be 3 by 3. So this should be 3 by 3. So this is 2 times, this is 2 by 3, 3 by 2. So 3. So 2 times 6 plus. So we have messed up. It's not that way. I think we have made a mistake. It should be, this should be multiplied. This one should be multiplied by that. So this again. So it should be A times B should be 2 times 6, 2 times 6, plus 4 times 1. Then we have 1 times 1 times 6 plus 6 times 1. Then we have 8 times 6 plus 1 times 1. Then you proceed to the next one. Will be this one and that one. So this one will be 2 times 9 plus 4 times 2. The other one will be 1 times 9 plus 6 times 2. The other one is be 8 times 9 plus 1 times 2. The third one will be 2 times 10 plus 4 times 4. Then the other one is 1 times 10 plus 6 times 4. The other one is 8 times 10 plus 1 times 4. So you work out these ones and you shall obtain your matrix. So this is 2 times 6 is 12. 4 times 1 is 1. So that is 16. 1 times 6 is 6. 6 times 1 is 6. So this is 12. 8 times 6 is 48. 48 plus 1, 49. 2 times 9 is 18. 18 plus 8 is 26. 9, this 1 plus 9 is 9. 9 plus 12 is 21. 8 times that, 8 times 9 is 72. 72 plus 2 is 74. 2 times 10 is 20. 20 plus 16 is 36. 1 times 10 is 10. 6 times 4 is 24 plus 10, that is 34. 8 times 10 is 80. 1 times 4 is 84. So this is 84. So you get your answer there. So you can see the resulting answer is a 3 by 3. You can see how we have gone ahead and to do the multiplication. In this case, is a 3 by 3, and the final answer is this. It's a 3 by 3 matrix. That's that. Now, that being the case, we may wish to proceed and look at a past paper here and see what to summarize on this discussion. And this is July 2019. So July 2019, we want to see what happens here. So I'll write these questions on the board so that you can proceed and follow what is to happen. Now, this paper, July 2019, question 1A. So the question 1A, you've been given that A you've been given to be 20. This is 0.5. This is 10. This is 10. This is 0.8. And this is 15. And then B, you have been given to be 0.5, 0.8, 0.4. This is 10. This is 0.5. This is 10. This is 20. This is 10. This is 0.3. Then C, you've been given to be 10, 0.5, 20, 10, 0.8, 10. Then you want number 1. The first one you've been told B times C. Now B times C, you have, there are two matrices. It is simply B times that. So you have to check them for compatibility. Let's see. B is row times column, 1, 2, 3. So 3 rows, columns 1, 2, 3, 3. What about C? You have to check them for compatibility R times C. So how many rows do we have there? 1, 2, 3. There are 3 rows. And how many columns are 2? So 2. So let's see. This is 3 by 3. And this is a 3 by 2. So you can see they are compatible because the columns, the number of columns in the second row for the second matrix, the same thing as the number of is the same as the number of rows in the second matrix. So they are compatible for multiplication, and the resulting answer will be of the 3 by 2 matrix. So that we can do now. B times C. So we can now proceed and have a B. So B times C, B times that is 0.5, 0.05 times 10 times 10 plus, so 0.10 times 10 plus this is 10, this is, so let's arrange it so nicely so that we don't get confused with what we are doing. So this is C is 10, 5, this is 20, this is 10, this is 8, this is 10. So we shall be having the resulting matrix. We have said this are 3 by 3. That one is 3 by 2. So the cell matrix will be 3 of the cell matrix will have 3 rows, 2 columns. So the columns will be 2. So this one, that one. So we have 5 times 10 plus 10 times 20 plus 20 times 8. Next, 8 times 10 plus 5 times 20 plus 10 times 8. Next, 4 times 10 plus 10 times 20 plus 3 times 8. Then we proceed. The next item here, it will be this row, this column, this row, this column, this row, that column. We shall be having 5 times 5 plus 10 times 5, 10 times 10 plus 3 times 10. So that's that. Then we have 8 times 5 plus 5 times 10 plus 10 plus 10 times 10. Then the other one is 4 times 5 plus 10 times 10 plus 3 times 10. So in this particular case, if you summarize it, you will be able to get a 3 by 2 matrix, and that's what we had there, 3 by 2 matrix from that multiplication. Now that's that. Then the second question, because the first one was for you, the first item was for you to multiply B times C, which you have seen. The second one was to A plus C, and the third one was basically C minus A. And in that case, all of it was giving you 8 marks. Now we have seen on how to go about the multiplication. We proceed with the additions. And we have said that for us to be able to add, the matrices must be of the same order. So the matrices, the A and the C, we check for compatibility. So you can see this is a 3 by 2 matrix. This is also a 3 by 2 matrix, and therefore we are able to add. So A plus C will simply be you add the corresponding elements. So 20 plus 10, 5 plus 20, 10 plus 8, 10 plus 5, 8 plus 10, 15 plus 10. So we have there 20 plus 10, that is 30. 5 plus 20 is 25. 10 plus 8 is 18. 10 plus 5 is 15. 8 plus 10 is 18. 15 plus 10 is 25. That is the addition. You have to check it first. I have to check first that the matrix that has been provided, they are of the same order. Otherwise, if they're not of the same order, then it is not possible for you to carry out the addition. Then that's that. We have done now this. We go to the subtraction. So subtraction there is C minus A. So again, C and A. So C minus A. So C minus A becomes 20 minus 10, 5 minus 20, 10 minus. So you can see all the elements of A becomes A, and all the elements of A become C. And because it is A minus C, so the item of A must come first, then followed by the item of C. So you shall be having 20 minus 10 is so 20 minus 10 is 10. 5 minus 20 is negative 15. 8 minus 10, 10 minus 8 is 2. 10 minus 5 is 5. 8 minus 10 is negative 2. And 15 minus 10 is 5. And so that gives you the matrix addition, subtraction. So you have seen from our discussion that at this juncture, if you are given a matrix to subtract, a matrix to add, and a matrix to multiply, whether by another matrix or by a scalar, you are in a better position to be able to answer that question appropriately. Otherwise, that is the end of our discussion on this version of matrix. Thank you.